This week we're going to go over chapters 3 and 4, and we're going to talk about some really, really big key ideas in time value of money and some other tools that you can use to kind of figure out how to view money and also how to properly value it in relation to time. Probably the biggest idea that we get in this class is through this. So that being said, let's begin. I ask at the beginning of this section, I think, or at some point, you will need a financial calculator or access to a financial calculator tool. And so I'll explain what that means shortly, but there's plenty of places online and even on your smartphone to do that. A really, really, really key component to this class is figuring out how to value investments and loans over time. So that being said, it's all based upon the idea, and chapter 3 is really the big concept here is this fact. It is that money is dynamic. And what I mean by that is that basically there are outside forces that are always acting upon money and its value. And basically it makes money change. It's not a static thing. It's something that changes. And so basically, typically we think of two opposing forces that work for you and against you, and one being inflation. And inflation, obviously, as you know, devalues money by watering it down. And then you also could, if you invested that money, have a force working for you, which would be a return on investment, which increases the value of your money. So because of those things, we don't look at a dollar today as having the same value as a dollar we would receive tomorrow. And we don't look at a dollar today being equal in value to a dollar in 30 years. Proof. Would you rather have $100 today, or would you rather have it a year from now? Apart from the fact that you might forget about it if someone offered you that money. I think you'd rather have it today, right? Because the financial answer is you could invest it and you could probably have 105, 110 a year from now. So, and I guess the next question would be, well, it depends on how high of a return I could get on that $100 in order to answer that question, whether or not I'd rather have 100 now or 105 a year from now. So the big idea is understanding these concepts. And so we'll be using these terms a lot. So I always kind of like to start with the important terms that you might not get otherwise. And so a principal is the original amount that you start with in investment. FVIF stands for future value inflation factor. And basically what that is how much you could get in earnings with how many years you invested something can inflate the amount of money that you have. So you typically, it would be like 1.5 times, 2 times, 3 times, so forth. So that an annuity is a series of equal periodic payments. So typically we will be talking about annuities when we do these type of formulas. And again, this is probably the heaviest math we'll get into. I promise it's not that bad. I'm not a math guy myself, but you'll be able to figure it out, I promise you. Discounting is the time value of money working backward. So basically, instead of saying, how much is my $1 worth in the future, you would answer the question, how much is $1 in the future worth today, whenever you factor in the forces of money. And that would use PVIF, which is present value inflation factor. So all that being said, the simple math is we need to learn compound interest. Compound interest is a really, really cool factor. Albert Einstein even went as far as to say it is one of the most powerful forces in the universe. People are always asking, what's the key to being rich? What's the key to being rich? Well, compound interest is required in order to get there. So basically it works like this. If you deposited $100 in a savings account and you earned 4%, so probably can't do that now in a savings account, but maybe 20 years ago you could have. In year 1, you would earn $4. So you'd have 104 in your account. And in year 2, you would earn not only money on that $100, which is, again, that term principal we use, but you would also earn it on the interest you earned the year before. So you would actually earn $4.16 that next year, totaling $108.16. And it doesn't sound like 16 cents as much, but whenever we start using compound interest, we're working with exponents. Okay, this isn't like a multiplication question. And when you're working with exponents, it's going to be parabolic in the way that it grows. And so in year three, we would earn $4.32. We'd have $112.48. And gradually and surely you would see that growing more rapidly in terms of interest, which is exciting. I think that's how people become rich. So this kind of explains the elementary math of how you could solve it. So basically, how do you solve for compound interest? Well, you could kind of do this like 10, 15 years out, but man, what a pain, what a waste of time. You could use future value inflation tables, which basically find the value of an investment by finding this multiplier. It's the 1 plus I part of the equation that we'll look at. C.1 in your appendix in your book has a whole bunch of them, but basically they look like this. So you would use it by following period, which is years right now. Let's say you took it down to 5 years. All right, let's say you earn 5% interest for 5 years. You would be able to multiply your money by 1.27 to arrive at how much money you have. So hopefully that kind of makes sense. A lot of people use these. These are great whenever you're working with a lump sum investment that can grow over time. And it's kind of neat and exciting because you could see like, man, you know, if I could get 10% interest, which may be a little bit high, but not unreasonable, for 25 years, I would grow my money at 10 times, right? So that's not bad. You start with $1,000, you have 10,000. You start with $10,000, you have 100. So that being said, you could use that. You could also use the algebraic equation, which kind of follows this. S equals P with the sum of 1 plus I to the nth power. So solution is S. P is how much money you start with. I is your interest rate stated as a decimal point. So like 5% would be 0.05. And your N is years. So ultimately, if you had that $100 invested at 4% interest, you'd be able to get the same number there. 1.04 to the third times 100 is 112.48. If we go back here and look at that 4% for 3 years, it would be 1.1249, which makes sense, 1.1248, same idea. So all those options are great when you invest a lump sum, but often there is another variable at play. Let's say you have additional investments that you include into that original amount that you total. So for instance, let's say you started with $100, right? But then you add $25 per year to the account. How much do you have in 3 years? Well, that's a little bit tougher a question to answer. That's why we want to have a financial calculator, or at least a financial calculator tool to answer that with. And so this is what one looks like. If you're a part of the financial planning major, you definitely will need this. If you're a business major, I'd recommend you getting one. And if you're not, I'd recommend finding one online or available to you somewhere else. There is even an app that looks just like this that you can download for free. You can even push in all the buttons just like this one can. I tried to install it on my work computer, but the firewall wouldn't let me. So you're more than welcome to use that. There's also other places online to do that with. Let me find one for you. Whoops, forgot I'm not sharing. I'm only sharing this, so hold on a second. Any questions so far up to this point? I'm going to go fast. I apologize. So here's an example of an online time value of money calculator. It's always going to have these buttons. You're always going to have periods, which is the N on your calculator, rate, which is the I on your calculator, like interest. You're going to have the present value, how much you started with the investment, and the payment. So if you looked at that question earlier, it was for 3 years, 4% interest. You started with $1,000 and you're adding, or was it $100? You're adding $25 a year, okay? And then all you have to do is hit future value, and you would see you're going to end up with $190.53. And actually, to be accurate, I need to state these in negative, and this is positive, which we'll understand in a minute why we will have to do that. All right. What's your turn? So this is the financial calculator, what one looks like. My favorite is the HP 10 BII. I've got the BII Plus. This is the regular BII. Great financial calculator, pretty similar to there's also a Texas Instrument that's very similar to that. Pretty powerful stuff what they can do though. Pretty cool. So some of the pointers that we have, we always want to clear our calculator before we use it. And basically on the calculator, you would do this, hit the second, the clear all and then one, or excuse me, the second clear all and then one. And what that does is it clears everything for you. Because if you enter in a digit, it's going to save it. All right. So like, for instance, on this financial calculator, if I wanted to have an investment for 3 years, be my N, I would hit the 3 button and then the N button. All right. So that locks in 3 and then 4% I. Present value would be 100 and then lock that in. And you would want to state that as a negative. So it'd actually be 100 to the negative. And then payment would be 25 negative. And it would be like kind of an accounting thing. That's why we use a negative there. Basically what you're saying is you're taking money out of an account you have and putting it into an investment. So you don't have it in your account anymore. That will state the future value is positive. Now, if you mix up those symbols, those positive, negative symbols, all it will do is make the future value reversed unless our PV and PMT, one's positive and one's negative, which might be the case. Let's say we started with $100,000. We're gaining interest on that, but we want to take money out of that, right? So 100,000 would be negative. Let's say we wanted to take $1,000 that out a year, that would be positive. So anyway, we'll go over more of those examples here in a little bit. So basically what we want to do is we want to typically solve for future value, but you can also solve for present value here. So a question would look like this. Say you wanted to have $50,000 saved for a down payment on a home in 10 years. You know you can get a 9% return on your money in those 10 years. You will not add money to your investment. How much do you need to have right now to reach your goal? So you can see how this question might really be helpful in personal finance, right? This is a common thing that you typically have, a goal that you want to save for. You know you can get return on your investment, so you put that money into the market for 10 years. How much money would I need presently? So let's go ahead and answer that question right here. I'll have to go back and forth. All right, let's say you have $50,000. Oh, you want $50,000, right? So that's our future value. That's our goal. Let's say we have 10 years to let it grow at 9% interest, okay? We don't add any money to it. We just need to know how much money we need now. And so if we solve for PV, we're going to end up with this amount. All right, if we had $21,000 right now, in 10 years, investing it at this much, we would end up with our goal. So that's how that works. Any questions there?
No.
All right, good deal. Hello, Lorena. Nice to see you.
Hey, how are you?
Good. All right, let's talk a little bit about the terminology. In the big financial world, we typically use the term annuity, and that means that it's going to be equal periodic investments we make, and basically we will use the PMT key right here. Ordinary annuity means that we're making a payment at the end of a payment period. An annuity due means that we're making it at the beginning, and that's going to change the numbers around a little bit. Financial calculators have a beginning and end button. So if you look here, I might be covering it up. But anyway, basically, you would take second, which is the yellow, and then you would type, there's end right there. If you hit that button, it's going to show up beginning or end. And typically, end is standard and beginning is not. So right here, the calculator, if you look closely, does say beginning. And so we're actually working with and. That would be an annuity due, okay? If you mess it up, your numbers will be slightly off, which might be good to remember if you're answering this question in a multiple choice setting. Always ask the question, is the payment being made at the start or in the payment period? We also want to typically set our calculators to solve for one payment per year. So now, like if you look at this question or look at the time value of money calculator, I like look in here. This is kind of set up so it says periods, not in. Okay, so if we were to use a monthly system, which we might if we're talking about a home mortgage or something, we might have 36 periods and only be talking about 3 years per month, right? Well, if that's the case, then our rate is going to have to be changed in order to account for that, because 5% per month is very different than 5% per year, right? And so what we would do is we would take 5 divided by 12, and it would be 0.411 or actually 416 per year. So that's something else to keep in mind. Okay, and that's why we typically want to set our financial calculator, all right, to one payment per year. And you would do that. It's really simple. Typically, you would hit, there's a P-YR number, which should be about right here. And if you hit second or one and then the second button, the PR, it would do that. And that would basically make it one period per year, which typically we will do. We'll talk about, APY is annual percentage rate. Talk about how many years an investment would be, which would be our end. So let's look at this example. Imagine you invested $15,000, all right, and it earns 6% for 24 years. It compounds annually. You would have $60,734. Now imagine that you did that and it compounded monthly. Okay, so basically what it's saying is at the end of each month, it's going to compound. All right, not 6% per month, but 6% per year, but compounding at 0.5% every month. All right, well then if you worked that out, you would have to multiply n by 12, and we would have to, which would give us 288, and you have to divide your I by 12, which is going to give us 0.5. I actually should read 6 divided by 12. And you can see how the numbers are slightly different. All right, more compounding periods gives it a little bit more time to grow. All right, let's move on. Other types of time value of money questions that we deal with kind of look like this. Imagine you're offered an annuity. It costs you $5,000. It will pay out $300 annually for the next 12 years. What interest rate is this offering? So we can solve this by always filling in all of these blanks. There's one left empty, okay? That's not present value or payment. We can solve for it. So here, we're trying to see if this would be a good investment. Like an annuity is something you would buy for a retirement account. You take a lump sum, you put it into this thing, and it grows out a percentage per year, pays out a number per year. So it cost us $5,000, okay? It pays out $300 per year for the next 12 years, and then it would be worth nothing because they're not going to pay any more for that. So we would spend this much. We're going to get this much back annually for the next 12 years. What is our rate going to be? And so we're going to solve for rate. It's going to be 4.72%. All right. Now imagine you can get 8% on alternative investments. Is that a good deal? It turns out it isn't, because if we could get 8%, we would have $6,897 out of our $5,000, even if we took $300 out per year. And so that's another kind of question you might see. That one's a little bit more complicated. Don't you understand? Because you're taking money out. You put money in, and you're taking money out as well at the same time. So let's move on. All right, let's look at this one. Wile E. Coyote believes he can earn 15% by investing in the stock of Acme. If he invests $500 annually over 20 years, all right, so $500 annually every year, okay, so $500 is going to be our payment. Try to clear these out. 20 years, year periods. How much money will he have? Okay, he thinks he can earn 15%, so might be a little bit foolish because that's pretty high. We didn't start with any money. All right, notice he didn't have a lump sum he invested in at the beginning. Our future value is going to be $51,000. Let's see if we can only achieve 7%. Future value is going to be $20,000. Oh, that's a big difference. So that's how you answer that question. Let's look at the next one. Common Carl wants a nice boat. Costs $90,000. He believes if he saves $1,000 a year for 20 years at 1.5 interest, he'll be able to buy that boat with cash. Is this the case? Yes or no? So we don't want to solve. We're going to solve for future value, but we're going to compare it to that $90,000 goal. Okay, so let's say, again, he doesn't have any present value. He's going to save $1,000 a year for 20 years. So, man, he's a long-term thinker here. But you can only get 1.5% interest, which isn't much. Let's see what the future value says. Nope, nowhere close, right? Even if he could get maybe 10%, he's still not going to make it, right? So he's going to have to realize he's going to either have to up his payments, wait longer, increase the rate by investing in riskier investments. That's his only option. All right. So if you want to, you're more than welcome to try to buy one of these calculators. I think it's a very, very useful tool to have in life in general. Of course, now there's so many options, even online or even with your cell phone, that you don't probably need to buy one. I use Android. I have an app called HD12C, and it has the same kind of deal. Let me stop sharing here. Okay. So it looks like this. Got all the different features on it. It does have ads, so you got to watch out for that. But I'm sure iPhones, Apple iOS store is going to have options as well. I kind of like this one because I don't know, it fits, right? You're not always going to be around your computer to use the online apps, and it has all of the different features that you would typically use. Basically, if it has N, I, PV, PMT, and future value, FV, it can work. All right. So, questions for this class. At what percentage and N would it take to double your money? Okay, so there is a fun little rule that is kind of easy and simple and works really well if you're trying to kind of do a quick and dirty way of figuring how long it would take an investment to double, and it's called the rule of 72. Basically, it's simple as this. Take 72, divide it by the interest rate you think you can get, and that's how long it would take to double your investment. So for example, if you got 9% interest, it would take about 72 divided by 9, 8 years to double your money. And I will ask that question here and there periodically on quizzes and on your final, because it's easy. It's an easy question. It's an easy thing to remember. I think it's helpful whenever you guys are thinking about, there's going to be a lot of times when you think about retirement or investments and you want to know how much money would I have in 10 years or in 12 years or in 9 years. And you can use that rule of 72 to kind of gauge where you could be in the future. It's really useful and easy, and kind of a way that the time value of money just kind of works out. I don't have any idea on the math behind it. It's calculus, but it works. So if you look at these future value inflation factors, it will tell you the answer there, right? So again, if you take 72 divided by 9, okay, you're going to come to 8. 1.99 is how long it takes for an investment to double. That's what the future value inflation factor is telling us, right? And if you keep moving on, you'll see that 10% at 7 is pretty close. 11% would be somewhere between 6 and 7, closer to 7. 12% would be right close to 6. 13%, you get the idea, right? 5.5 or something like that. But kind of an interesting idea. So I know I went through this quickly, and this is a big part of this class. As a matter of fact, you're going to have a lot of questions on your quiz this week about the time value of money. I would recommend doing the examples at the end of your text, or even just going through the examples I give you here, trying to figure out a way that you can answer them and get them correctly using a calculator or using an app or using the online option. But anyway, here's kind of my implications for this. Compounding is powerful, all right? Time plus money equals excitement. It really does. It's a shame because we like to think in our little brains that, what do you say, that you could somehow become rich if you wake up tomorrow, right? Like that's all of a sudden become our American dream in our instantaneous gratification world. Truth is, not so much. It's just not the case. Compounding can powerfully work against you as well. If you have debts and you choose to delay payments, I think that's a pretty good example of that. I guess I need to share this, don't I? Time value of money should excite you to save, because most of us here are young. You know, I'm a young person as well, not too old at least. But time's on your side. And when time's on your side, you can do pretty incredible things, right? Say you just wanted to invest $100 a month. We'll talk later about how to invest it, all right? But if you invested $1,200 a year, you started with zero money, you invested it in the market and got 10%, and we're all young here, right? So you expect to work till 65 or 70. That would be 50 years. You would have yourself $1.39 million, right? So that's pretty exciting, I think, to think that you could invest just $100 a month for the next 50 years and have yourself a cool million. I don't know. But it's been said, youth is wasted on the young, right? And I kind of get that idea now that I'm done with my 20s and on to my 30s. So saving and investing is a great example of that. We can all save. We can all do it. There are ways to cut back, even if you're in college. I know you have debts and probably loans that should be paid on before you consider the idea of investing. But the quicker you can get past that stage, the quicker you can get to worrying about your future. Maybe worrying isn't the right word, but taking care of so you don't have to worry about it once you're 40 and 50. So many people say these words: if only I had started to save when I was young. Compounding interest would have made me fill in the blank. All right? Rich, mortgageless, financially secure, wealthier, able to afford whatever you want. All right? I've heard them say before, live like no one else now, right? So you can live like no one else later. And if you save your money and invest it wisely, compounding interest and the time value of money tells you that it could be a good story for you. So anyway, any questions? All right, I'm going to pause